Hey there! Here we go into the second video on the disk method. And in this one, we're going to see that we can use disks to revolve regions that are pretty funky looking. Right? In the last one, we looked at a cone and a cylinder, but let's get crazy. So this says, find the volume of the solid made by revolving the following bounded region about the x-axis. Okay, so we're revolving about the x-axis. Here we go. Root x. All right, what does that look like? Well, the square root of x looks like this. Like so. It makes that sound. You just have to listen carefully. X equals 9. Something like that. That'd be a vertical line. And then y equals 0. So your region is right in here. So when we revolve that about the x-axis, you basically get to mirror this whole thing down here like this. And we're going to end up with kind of a funky looking bowl, except the bowl is not hollow. Right? It's quite solid. It'd be very frustrating to put ice cream in it. You'd be putting it on it, I suppose. So what we're going to do is find the volume of this thing. And remember, what we do is we find the radius, which is the distance from the outer edge to the axis of rotation right there. So that's r. So r is equal to that minus that, or root x minus 0. Make it very simple. Literally just do that minus that and then correspond that with what the actual functions are. So that's going to be equal to root x. Now we know that our integral that we're using is pi times r squared dx. We're stacking them left to right here. We know that because we're perpendicular to the x-axis. And so that's going to be from x equals 0 to x equals 9. And now we're just going to plug in what r is. So that's going to be pi times the integral from 0 to 9 of r squared, root x squared dx. And I just want to pause and kind of mention, we're now done with the new part, right? The rest of this is just straight up integration. I did not draw a disk in this one problem here because I showed that in the first video. You can continue to draw disks if it helps you to kind of visualize what's going on here. But the radius, again, the distance from the outermost edge to the axis of rotation. So I've got pi times the integral from 0 to 9. Root x squared is x. Oh, it's beautiful. That antiderivative is super easy. So pi times x squared over 2 from 0 to 9. And now we're going to just evaluate in the upper and lower bounds and subtract with the fundamental theorem. So it's going to be pi times 9 squared over 2 minus pi times 0 squared over 2, which is easy. That's going to go to 0. We're left with 81 pi over 2. That's it. That's all there is to it. It's pretty sweet. Again, we recognize it's a disk because the region that we're revolving was flush up against the x-axis. All right, on to the next part and last part of this video. It's going to be a pretty quick one. I wanted to show you some functions where we revolve things and they're curved functions, right? It's very cool solids we're getting here. Find the volume of the solid made by revolving the following bounded region about the line y equals 2. Interesting. Here we're revolving about the line y equals 2. So that is right up here. So this is now our axis of rotation. The axis of rotation sounds like something evil. Axis of rotation. Okay, so here we go. The square root of 9 minus x squared and g of x equals 2. So actually, what we're revolving about is part of the region. Interesting. So I'm now going to make it a solid line to show this part of the region. And then we've got root 9 minus x squared. If you didn't know that that was a semicircle, I'm telling you now. So it looks something like this. It would be just a piece of the semicircle. That thing actually keeps going down. It would be like a semicircle that keeps going down to here, right? But we don't need all of that. We just need this piece right here. So I'm going to erase everything that I just put in place. Just wanted to show you that it's a semicircle technically, square root of 9 minus x squared. But we only care about that region there where it's bounded. So now we're going to rotate it. And when you rotate that, you essentially get something that looks almost like a football. Pretty cool. Notice though that the region is flush against the axis we're rotating about. Right, y equals 2, and so this is a disk. I draw in my radius. Here it is. It is the distance from the outer edge of our region to the axis of rotation, and that radius will change as we go to different parts of this shape. And so like before, we've got pi, antiderivative from a to b. We've got to figure out what those are. More on that in a little bit. Times r squared. Well, that's r. Right, that's the radius. So we're going to figure out what that is. So what is r? Well, r is this minus that, or this minus that. It's top minus bottom, like in area. So this distance here from the outer edge to the axis is f of x minus 2, or square root of 9 minus x squared minus 2. That's it. That's going to be your radius, and we're going to square that thing. So you get pi, integral from, we'll have to figure out the bounds shortly, square root of 9 minus x squared minus 2, all of that, squared. Now let's see what that ends up being equal to. But first, we got to find these intersection points here and here. So we'll set f equal to g. So I set 2 equal to the square root of 9 minus x squared, and I square both sides. We'll get 4 equals 9 minus x squared. And then from here, I'm very simply going to subtract 4 and add x squared. And so x is equal to plus or minus the square root of 5. That's where we intersect there. Ugh, not very nice values, but we can handle it. Minus root 5 plus root 5. Now, when you go to anti-differentiate this, it's going to be a little gross what we get out. And you'll likely be able to use a calculator on this one. So this guy, I'm going to make a graphing calculator problem. The reason being is you haven't learned yet how to actually integrate part of what will happen when you square this thing out. So we get our setup. We're going to say equal to, and through the magic of video editing, I'll be back at you with an answer very shortly. Hey there, and well, through the magic of video editing, here's the answer. Don't forget to have a pi next to your answer. That's one of those things that we go to our calculator and we often forget putting a pi down. So 2.517 pi, and if you plug that answer into your calculator, you get 7.907. That's me truncating. I'm not a big fan of rounding. I guess it would be 7.908 if you round it up. So any of those numbers work, but the important part here is the setup. Just like I advised you with area, get to the setup part and then go to the next problem. Then set the next one up. Do 5 or 6 of them like that so you're practicing the concept, not getting hung up on the integration. That was a fun one. See you in the next video. Peace.